Hello, this lesson is on comparing functions. All right, we're going to start out with rate of change, which is something we've already discussed and we learned a lot about in our last unit. We can compare functions by looking at their properties, such as slope or rate of change. Remember, rate of change and slope mean the same thing. To find the rate of change, use the slope formula. If we recall, the slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Or we can think of it as comparing the ratio of rise over run, rise divided by the run. Okay, we're going to jump right in and we're going to look at some different problems, and the directions say practice finding rate of change in the following examples. So if we look at number 1, we have an equation, and so far we've dealt with equations that are in this form, which is called slope-intercept form, where this m is the slope and the b is the y-intercept. The b is where the line crosses the y-axis, and the m is the slope. It tells you how the line is rising and running. Now, of course my pen just started to die, so let me plug that in for just a moment. All right, so if you look in that equation that says y equals 2/5 x plus 9. If we have to write what the rate of change is, and we know that the rate of change is the slope that we're looking for, the slope, remember, is the coefficient of x. It is the number that is multiplied to the x. So that would be 2/5. Let's look at number 2. Now we have two ordered pairs. Remember, we have our x first and then our y coordinate. And in order to find the slope, we do our rise, which means subtract our y's, divided by our run, subtract our x's. So I'm going to do 9 minus 7.5 divided by 6 minus 5. And you're welcome to use a calculator if you need to. 9 minus 7.5 is going to be 1.5. divided by 6 minus 5 is 1, which is the same thing as just 1.5. So that is the rate of change looking at a pair of ordered pairs. If we look at this table in number 3, remember a table is nothing but a set of ordered pairs. See, here's an x and a y pair. Here's a 7, negative 11, and 9, and negative 17. So we are going to, all we have to do is pick 2 that we need. So I'm going to erase this last one so we aren't looking at that. And we're going to need to use these 2 ordered pairs to find the rate of change. Now remember, we subtract the y's as our numerator. So we need to be looking at the negative 5 and the negative 11 for our numerator. So a negative 11 minus a negative 5 divided by 7 minus 5. We subtract our x coordinates on the bottom. Now, if you're using a calculator, that's fine. You should be able to calculate the numerator pretty easily. If you're not, think about this as keep, change, change. So we have to do that extra little step. So a negative 11 plus 5 is going to be negative 6. And 7 minus 5 is 2. Negative 6 divided by 2 is negative 3. So my rate of change is negative 3, or you could write negative 3 over 1. Number 4, looking at a graph. Remember, when we're looking at a graph to find the rate of change, we have to find, we have to go ahead and emphasize some of the points on our line. And so it looks like at 0, 1, that would be a good place. And then 4, 2, 8, 3, those are some good locations. Now, we really only need 2 of those, and we need to find the rise and then the run. So if we look at our rise, it's only going by a difference of 1, and then our run, that's 4, so the rate of change is 1/4. Okay, number 5. Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. Okay, so Ty is making 7 signs every 2 hours. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in this table below. Who is making signs at a greater rate? Okay, so we're looking for whose is greater. Well, in order to do that, we need to compare the rates. Excuse me. So if there's a couple of ways you could go about doing this. One is if you know that Ty sells 7 signs in 2 hours, and then you come over here and look at Harrison, he sells 15 signs in 4 hours. So we don't have a 2 hours on here. We have 4 hours. Well, if we want to compare this one, if this is 4 hours and this is 2 hours, we could double this 2 hours and make it 4 hours, which means we would double the 7 signs and we would have 14 signs. And so if Ty can make 14 signs in 4 hours, but Harrison can make 15 signs in 4 hours, then Harrison must be making signs faster because he's able to make 1 extra sign. However, if we want to look at this as a rate, like what we've been doing, I think probably it would be best if you looked at it like this: 7 signs and 2. I wrote that wrong. I'm sorry. 7 signs every. No, that was right. 7 signs in 2 hours. That would divide to 3.5, which means he can make 3.5 signs in 1 hour, which really he's not going to make a half a sign, but he's almost to the next sign. All right, and then if we just take 2 ordered pairs here and we subtract our y's, which would be 30 minus 15, and then 8 minus 4, subtract our y's on top and our x's on bottom, we get 15 divided by 4, and 15 divided by 4 would be 3.75. So he can make 3.75 signs in an hour, which means that Harrison is making signs at a greater rate. And we could write Harrison, and then we can write Harrison's rate is 3.75, and I'm running out of room, sorry. Ty's rate is 3.5. After 12 hours, what would be the difference in the number of signs that each friend has made? Okay, so first of all, if we look at our table here, we see 12 hours. So we know Harrison can make 45 signs in 12 hours. So I'm just going to write H, and I'm going to write 45 signs because we know he can make 45 signs in 12 hours. But how many signs can Ty make in 12 hours? Well, we know that he makes 3.5 signs in 1 hour because that's what his rate was. So if we do 3.5 times 12, that's going to give us, if you want to use your calculator, you can. It should give you 42. And so then the question asks, what would the difference be? So look at the 45 and the 42. What is the difference? Which means to subtract. It's a difference of, 3 signs. Okay, Julie's family is filling up the pool in her backyard. The equation y equals 5.2x plus 8,500 can be used to show the rate at which the pool is filling up with water, where y is the total amount of water in gallons and x is the amount of time in minutes. Her neighbor, okay, so hold on. So we got Julie, and this is Julie's equation. And then we've got her neighbor, Elena, is also filling up their pool as shown in the table below. So we have a table to show us Elena's situation and an equation showing us Julie's situation. Okay, Whose pool is filling up at a faster rate? Well, we know if we look at Julie, her rate is 5.2 because we know that that's slope, and slope is always right there in front of the x when this is in slope-intercept form. But for Elena, we're going to need to find, pick two ordered pairs. And I'm going to pick these two. So then we're going to do 7,874 minus 7,850 divided by 5 minus 0. So that's going to give us 24 divided by 5, which is 4.8. So whose pool is filling up faster? Elena's has got a rate of 4.8. Julie has a rate of 5.2. So I think we could agree that it is going to be Julie. And it says, how do you know? Julie's rate is 5.2. And Elena's is, what did we say hers was? 4.8. All right, we're going to come back to number 7 here in a minute. Go to number 8. It says to compare the slope in the equation. Okay, so we're comparing an equation with the slope shown in the ordered pairs, which has a greater rate of change. So we're doing exactly like we did with the pool problem, just not a actual real life situation here. So if we're looking for the greater rate, so what would the rate be looking at this equation? What is the rate? It is 3/5. Okay, so we know our rate is 3/5. The rate for the ordered pairs, we need to pick a couple. I'm just going to pick these last two. So subtract my y's, so 6.2 minus 5, and if it helps, you should do this. Okay, so 6.2 minus 5 divided by 7 minus 5 is going to give me 1.2 divided by 2, which is, if you divide it out, 0.6. So the rate for these ordered pairs is 0.6. And it says which is greater, so we've got a 3/5 we're looking at. If you do 3 divided by 5, it is also 0.6. So which one is greater? There isn't a greater one because both have a rate of 0.6. All right, number 9, Reese and Kevin have been working out together to try and lose weight. Reese's weight loss can be modeled by this equation. That's Reese. Okay. Y is the total weight and X is the number of weeks he's been working out. Kevin's weight loss, his progress is shown in the graph below. Who is losing weight at a faster rate? Okay, so we know Reese, if we look at his equation, what is his rate? It's -4. That means Reese must be, his rate is -4, which is -4/1, which means he's losing 4 pounds in 1 week. Because remember, the X is the number of weeks. All right, and then Kevin, in order to figure out what his situation is, if we look at our graph, we've got a point here and a point here. And you've got to pay attention when you do your rise. See, it does look like 1, but what's the difference between 200 and 180 there? It's actually 20. And then we're counting by 1s going across. So it's a rise of 20 and then 1, 2, 3, 4. And since the line's going down, it's actually going to be -20/4, which 20 divided by 4 would be -5/1. So 5 pounds per week. So who is losing weight at a faster rate? Kevin, because he is losing weight at 5 pounds per week versus Reese at 4 pounds per week. Good. All right, very good. The last one I want to look at with you is number 7. Now, with number 7, it says to compare the slope and each of the equations below. Circle the equation that has a greater rate of change. Well, we're not used to seeing our equations written like this just yet, okay? These are two separate equations, and they're written in what's called standard form. We are used to slope-intercept form. So we are going to go from standard form to slope-intercept form, which looks like this. And then we're going to compare the slopes. So just so that you can make sure that you don't get confused, we're looking at two separate equations here. All right, so we need to get this into slope-intercept form. So the first thing we're going to do is we need to have y equals. So we need to get rid of that negative 9x. So technically you're adding 9x to both sides of the equation, but I'm going to explain it to you for right now as we're going to move this to the other side, and when we do, we have to switch the sign. So we still have this positive 3y we're going to bring down. But if we take this negative 9x and we move it over here by the 27, it's a negative 9x, so it has to move over here and become a positive 9x over here. So it's positive 9x over here with the positive 27. Now, if that was a positive 9x already right here, then when we moved it over, it'd have to become a negative 9x. So it always changes signs. The last thing we need to do is we need y by itself, so we need to get rid of this. Well, this is 3 times y, so the opposite of multiplication is to divide. So we're going to divide by 3 here, and what we do to one side, we have to do to the other side. 3 divided by 3 is 1y, or just y. 9x divided by 3, 9 divided by 3 is 3x plus, and 27 divided by 3 is 9. So I think you can easily see the slope now in that equation, can't you? What is the slope? It is 3. All right, let's do the other equation. We've got to move the term with the x. You know, sometimes you might have the y first, but you've got to get rid of the x. Leave the y alone. So we're going to move this over here, bring down the positive 4y. When we move the negative 3x over, it becomes a positive 3x, and we already had the positive 24 over there. We're going to divide by this number that's in front of y. It's called the coefficient. 4 divided by 4 is 1y, or just y. 3 divided by 4 is 3/4, or if you want to write it as a decimal, it's 0.75 x plus, and 24 divided by 4 is 6. So where is your slope? It's right here. And which one is greater? Because it's asking for the greater rate of change. Well, 3 is greater than 0.75. So this equation is the equation that has the larger slope. And that's what it's asking you to do, is circle the equation that has the greater slope, greater rate of change. All right. Thank you very much.